I'm freaking late. I was doing a team project for like one of my classes, and it was like a divide and conquer kind of thing. Like, you go do this, I do this, you do that. And two of these guys did the same freaking part, dude. We were getting together at like 6 p.m. to like just do like review each other's stuff, and these two guys did the same part. What the heck, dude? So we had to freaking crank out the last part. Gosh. And I missed the freaking release time. Reconnected. Are we there? Are we there? I saw it lagging for a second. Okay, we're there. Yeah, still got to write a little paper tonight and do like a little quiz. You know, the next hour and a half. But I want to do this right now. So I'm going to go until 11. We'll see how much I get done in like 40 minutes. Let's go ahead and just make my file. Day 9. Do. Implements. Come on, where's my autocomplete? Wake up. Run. I might as well like add part 1, part 2 to those, but you know, we're this far into it. I'll do it next year. New file, test day. I might do it after this day. I don't know. Test day 9. 2 implements test day. All right. Let's see what we got for today. This is my input for today. Nice and small. Nice and small input today. And the tests, I mean, the tests are actually like the same every time. I could even implement, well, the only thing that's different is like the value, the expected. It's fine, I don't need to get crazy with it. Alright, what is the expected output for this? Is that what we're looking for? Let's read it. Amphipods, isn't that like a little freaking shrimp thing? What is an amphipod? Amphipod, it's like a brine shrimp, right? Or it's kind of like a sea monkey. Yeah, right. Are amphipods sea monkeys? No, sea monkeys are usually brine shrimp, right? Let me look at that amphipod again. I'm so distracted. Look at that thing. Kind of looks like a roly-poly / shrimp. Scramp. Here's a disk map. He's trying to make this contiguous free space by compacting all files, but his program isn't working. You're all for help. This is the disk map. The disk map uses a dense format to represent the layout of the files and free space on the disk. The digits alternate between indicating the length of the file and the length of free space. So length of the file, length of free space, right? So a disk map of 1, 2, 3, 4, 5 would represent 1 block file, 2 blocks free space, 3 blocks file, 4 blocks free space, yeah. Then block, 5 block file, yeah. A disk map of like this is, 9 block files in a row with no free space in between them. Okay. Each file on a disk has an ID number based on the order of the files as they appear before they are rearranged. Based on the order, right. Starting with ID 0. So the disk map 1, 2, 3, 4, 5, that's 0, 1, 2. 0, 1, 2, yeah. Yeah. Wait. Using characters for each block where digits represent the file ID and 1 is the free space. It looks like this. Right. Okay, so we got 0. We got file 0, empty space. So file 1, empty space. File 2, empty, that's the end. For example, this represents the individual, like, it looks like this. 2, 3, 3, 3. Wait. Oh, okay, yeah. 1. Yeah. Okay, simple. The amphipod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between file blocks. For the disk map 1, 2, 3, 4, 5, the process looks like this. Okay. Oh, wait. Was that 2 different files there at the end? 1, 2, 3, 4, 5. Oh. What? From the end. Oh, okay. Okay, gotcha. We gotcha. And then the first example requires a few more steps. Okay, this must be the first example. Yeah, this is the first example. Blah, 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 blah. So you move that 9 there, you move that 9 there, you move that 8 there. Okay, that's pretty easy. The final step of this file compacting process is to update the file system checksum. To calculate the checksum, add the result of multiplying each of these blocks' positions with the file ID number it contains. The leftmost box is in position 0. If the block contains free space, skip it instead. Yeah. So this would be 0 times 0, 0 times 1, 9 times 2, 9 times 3, 4 times 8, yada yada yada. And the sum of those is this. Compact the amphipod's hard drive using the process he requested. What is the resulting file system checksum? Cool. Is that all one line? Day 9. This one sounds pretty easy. Yep, that's all one line. Sweet. Okay. What are you mad at? What are you actually mad at? Okay, I don't have part 1 implemented yet. Or defined. Okay. Int part 1. Take that string data. It's going to be that line. So up here, string data equals readers dot file to string. I'll trim it. Dot trim. Part 1 data. Okay, so I got that data there. The first thing we want to do is make, I can kind of brute force this. Maybe, the most straightforward way to do this would be to simulate this process. So let's just begin with that because I got assignments to do tonight. And then we can get fancy later. So first let's make the so we'll decompress, and this will give us a, what are we going to do this with? We'll do this with a char array. This will give us a char array, decompress, We'll decompress that data. And then we will, what do you call it? Defrag. I'm going to call it defrag for now. And that will just be a void. Defragment. Char disk. Char red disk. Okay, so for the first part for decompressing, we are going to use the heck out of some streams right now. So I'm going to return arrays.stream. We're going to split that guy. Data.split. We're going to split it into its individual characters first. We're going to map each one of those. We're going to map each one of those characters to itself. Well. Yeah, how can we do this? Oh yeah, we can just have a little function body here. If it's even, first of all, maybe I should use int stream here. Let's do that. Int stream. Int stream. Dot range. We'll go 0 to data dot length. And we're going to map each one of these guys. Each one of these indices here. If I is even, well, yeah, if I is even, we're going to map it to itself times what? Itself times, wait, what? 0, 0, 0. It'll be the index divided by 2, right? Like this is 0, 1, 2. 2 divided by 2. 0, 1, 2, 3, 4 divided by 2. So, yeah, divided by 2. So the index divided by 2 times 0, 1, 2. 0, 1, 2, 1, 2, 3, 4. Okay. Itself. Okay. The index divided by 2. Itself. Okay, hold on. Yeah, it'll be the index divided by 2 times the index plus 1. The actual index plus 1. So that'll be... How can I do that? How can you, like, make a string? Well, we're doing characters, right? Yeah. Yeah, how do you make a string? I mean, you know, int copies string. I mean, I can just use that and join it. Yeah, that's what I was thinking. So shoot collections dot int copies. It's gonna be I divided by, no, it's gonna be I. No, wait. It's gonna be I plus 1 copies. I plus 1 copies of I divided by 2. Yeah. And string dot join that sucker right there. Return string dot join. String dot join that. What the heck? I don't know how that got in there. Else return Yeah, hold on. String val equals I is even. Is I even? If I is even, it's going to be this. Or it's going to be I divided by 2. String dot value of that. String dot value of. Else it'll be. Else it'll be a period. And then we can just return I plus 1 copies of val. What's the deal here? Yeah, we're not done yet. So we got it to collect it to a string. Collect collectors dot joining, and then we'll just dot to char array. Oh, this is doesn't that give us a string? Isn't this a string? No. What? Let's do something. I'm trying to see if that's why does it think that's fucking... Dang it, I said the F-bomb again. What is the problem with that? What is your problem? Huh? Should I say map? No, I think it's fine. I don't know why it's griping about that. It's something to do with IntStream. Maybe? What the heck? IntStream.range 0 to data.length .map. Each one of those string val equals, if I is even, it's going to be string dot value of I divided by 2. Else it's going to be a period. Return collections.endCopies of I plus 1 copies of val string.join. It's the exact same thing I had earlier. I know. Dot collect collectors dot joining. Don't even need those. Dang it. Dot to char. I should be able to say that. What? Maybe I have to map to object. Yes, that was it. Alright, so that will give me the decompression. Let's just test that real quick. Test that with the sample. Where's the sample at? Where's the sample at? Sample's small today. I can just put it up in here. I'll just make a file for us. It's no big deal. Day 9 sample dot text. Put that in there. Oh, just this part actually. Put that part in there. And let's rent decompress. Oh, let me think. Yeah, decompress. Yeah, I can do that. I can just say arrays.string. It's one dimensional. Arrays dot toString. One more. Okay. Do day 9. Whoop. Day 9 sample. Let's see what this looks like. Just make sure this looks right. Something wrong? 111. I see 5 2s. Is that right? Doesn't look right. No, it should be 0 0. What the heck? Wait. Oh, it is 0. 1 2. So it'll be the index times. Oh, in copies. It's self plus 1. Yeah, that many. But it should be the index. It won't be the index. It'll be the it'll be the index divided by 2, right? What are we getting here? 0. But it should be. Oh, that's right. Is that not right? There's see a single 2 there. Wait, what? Three. Huh? Wait. I did something wrong. 2. Wait, what? 2 blocks of file, 3 blocks of space. It's going to be, 3 blocks. It's going to be, the number of copies is going to be the number. It's going to be the s.charat. That's the number of copies. Yeah, what the heck? What was I doing? Some weird stuff. It's going to be s.charat. Integer dot parseInt data dot char at s or I. What? I honestly don't see what I did wrong here. Oh, it's a character. So just do what is it? Minus, how do you turn it into a character? Is it minus 0, right? So if I give you a 1 and I subtract 0, if I give you a 0 and I subtract, wait, what is it? Oh, it's plus, right? Like, so if you do 0 and I add the character 0, I get the character 0. If I get 1, I add the character 0, that gives me the character 1. Yeah, right. Okay, it's like that. That's definitely not right. What the heck? Oh, it's definitely minus 0. Right? To turn it into a... I think so. Yeah. 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 And one. Yep, that's right. Okay. That is right. That's how you do it. So it is properly decompressed now. Now that it's decompressed, we need to defrag. So we need to start at the end. This will be not that hard. So we need to start at the end. For int I equals disk dot length minus 1. I is greater than or equal to, let's see, this might be easier with a while loop. Yeah, this might be easier with a while loop. What if I did a while loop 2 indices? And then I move this part up until it's a point. And then I move this guy to there. This up to the point, move this guy until it's a number. Swap. And then move this guy up till it's a, yeah. While loop is probably better. I is going to equal, I'll just say left equals 0, and right equals disk dot length minus 1. And while left is less than right, we're going to do a while loop inside of here. While disk left is not equal to while left is less than right and plus left. Then you'll do something similar with right. While right is greater than left and disk right is equal to the period, move that sucker to the left, minus right. And then if disk left if left is data dot or disk dot length and right is greater than or equal to 0. Do a little swap here. Do I have a helper for that? No, I don't. I'll make one though, probably. Char temp equals disk left equals disk right, and disk right equals disk left or temp. Swap them. I feel like that should work. I really feel like that's all you need. Char disk equals decompress the data, return. Oh, now we want to defragment the disk, and then what? Oh, get the checksum. Get the checksum. Checksum. Disk. What was the checksum again? It's each number times its index. It's just each number times its index. For int I equals 0, I is less than disk.length plus I. If disk I equals a dot, we can get out. The sum is just going to be plus the disk I times I. Return that sum. Oh. Return checksum. Uh-oh, that's not right. Probably doing the defrag part incorrectly. So let's double check on that. So the defragged should look like that. So let's check on that. So defrag. Let's see if it's defragged correctly. Huh? What? Day 9? Why is it not printing anything? Oh, I have to call it, okay. Duh. That is that right? Ends in 2 6s. Oh, that actually looks right. Double check that. That looks right. Zero zero 998111888. Yeah, I'm defragging it right. So I'm not doing this part right. What is the checksum again? Yeah, it's times the index. Times the index. 2 times 9. 3 times 9. Oh, I'm dumb. And this will be... How do I turn a char into an int? It's plus... No, it's minus... Is it minus the 0? Yeah, it's minus the 0. That's what it was. There it is. Is that 1928? Is that what it was? Sweet. Alright, do the real one. Let's get rid of this. Do the real one. The real deal. Let's actually run our test too. Yeah, I don't think that will overflow today. Sweet. Alright, let's try this. And it is almost 11. I think I can knock out part 2. No, it's not right. That's not the right answer. Make sure you're using the full input data. Maybe it does overflow. Let's try it. It might. It's pretty big. It is pretty big. Long. Long. It's pretty large. Long. And both of these are integers, so I'm going to cast them both to longs before I multiply. Just, I don't want them to overflow. So see if I get a different answer now. Yep, dude, you gotta look out for that. Ah! Let's make sure we're passing our test still. I think that's what I had to do. I mean, I could just turn this into a... No, it needs to be an integer. Oh. Oh, yeah. Long. Long. Alright, run that output again. Yeah, dude, it was overflowing again. Crap. Alright, that was pretty fast. That might... That's still not right. That's the wrong answer. You think I'm overflowing? Let me see that data. Is there like a corner case I'm not handling? There's a lot of numbers. I actually don't even see any dots in here. What the heck? Oh, that's because this is the... Do you think I need to use big integer today? Probably not. But maybe. Should be adding them together, right? I'm doing that? Yeah. I feel like it's something to do with overflow. See if you get another answer. Nope, that's the same answer. Let's print out the length of the disk. How big is that disk? It's kind of big. Like how many things in that disk? Let's print out how many stream disk dot filter dot filter not equal to the dot count, please. Yeah, the heck it is. What are you talking about? What? That doesn't seem right. What? I can't stream a character array? You're lying. Really? That's it. Yeah, I guess not. Dang. Well, I just want to know, like, am I overflowing? What if I change it to a big integer? Let's try it out. Big integer sum equals new, or I'll just say big integer dot zero. Big integer dot zero. And this will return a big integer. I just want to see if it's overflowing. Comment that out. Comment that out. Would there be a case where anyway, say sum equals sum dot add fucking, oh, what was it? It's the value of the thing times new big integer. It's gonna be slow. And in here you want to do disk I minus this dot multiply big integer dot value of, oh that's right, I can use big integer dot value of dot value of dot multiply, this returns a big integer, right? Dot value of I, right? And let's just return 0 for now. And just print that big integer out. Checksum. That's the same answer I got. Is it not? Yeah, it's the same answer I got. What am I doing wrong then? Let's see. Maybe I can check. So I don't need to do any of that then. That's not the problem. Yeah, I don't think they would do that. Anyway, they wouldn't make it bigger than a long. So let's do some things. Let's do some checks. So after I defrag it, let's validate it. Validate disk. Void validate disk. So first, let's just go through. Let's use I equals 0 while I is less than disk dot length and disk I equals I equals the dot plus I. And now we're going to go through it some more while, same thing. no, that actually goes right there. And then here we'll just say this. If disk I doesn't equal period, we got a problem. Okay. So that part's good. And I passed the sample input, right? I must be missing like a corner case. I am missing a corner case or something. Well, I have to go do some assignments, so that's it for now. I'll probably jump back on in the morning.